Right, sample final exam A. You have 21 questions in this section. And the first question starts off with using your factor theorem to show that x plus 2 is a factor of p of x. So you want to think back to, okay, use a thinner marker. If we're looking at x plus 2, what does that tell us about our 0? Our x is equal to -2. And so using factor theorem to show that this is a factor, we just have to evaluate what our function is at, -2. Hence, wherever you see an x, draw in some parentheses. And then fill those parentheses with -2. Again, if you don't have a packet, grab one from the front. I have extra copies. -2 to the third power. -2 squared times 2. -2 squared is 4 times 2 gives you 8. And then -9 times -2. And -18. Ooh, what happens? All of this shoots too? Yeah. So is x plus 2 a factor? Mm-hmm. This really helps us out with our part B, where we are asking to now factor completely. So let me just write out the polynomial again down here so I don't have to keep scrolling. And now we know that x plus 2 is a factor. So we can use synthetic division to pull out an x plus 2. So how do we do that? Well, our c value is at -2, aka our 0. And then let's look at the leading coefficients for each one. Do we need a placeholder here? No, because we have our cubed, squared, linear constant. So our coefficients are 1, 2, -9, -18. And now let's carry out our synthetic division. Bring down the 1. -2 times 1 is -2. Take the sum, you get 0. -2 times 0 is 0. Take the sum, -9. -2 times -9, +18. Take the sum, remainder 0. Beautiful. And so now we have this x plus 2. And all of this, bringing back in our variables, becomes x squared plus 0x minus 9, also known as x squared minus 9, difference of squares. We're asked to factor completely. So x plus 2 and then x squared minus 9 can be factored into an x plus 3 and an x minus 3. And we're done. Yeah. Yeah, question? Mhm. You would get partial credit just because they are explicitly asking you to use the factor theorem. Yeah. If they explicitly say use the factor theorem to show that x plus 2 is a factor, you need to use the factor theorem. But if you do long division because you don't remember or don't recall the factor theorem, you will get partial credit. Same with the remainder theorem. You want to use the remainder theorem in order to find the remainder if you're given a factor in the problem. But again, partial credit if you use long division. Right. Question 2. We have the gray squirrel population in a certain region has a relative continuous growth rate of 8% per year. Okay, well, 8% as a decimal, I'm just going to write off to the side as 0.08. It's estimated that the population in the year 2013 was 18,000. So 18,000 is going to be that starting squirrel population value. And we want to find a function that models the population t years after 2013. So we want to think about this general formula, which I'll write out, and then I'll take a quick pause.
Sorry, I got to text.
Yeah, it's okay. So let me just write this out for you guys, and I will pause the. So we have our general equation when we're dealing with continuous growth. That's a key word that you guys want to look out for on your final exam tomorrow. If they put in continuous, you know that your equation is going to have our E in there. And so part A is asking us to just find a function that models this population T. So we're just plugging in what we wrote off to the side here, what our growth rate is, and then what our initial squirrel population is. And then once you do that, that's your result. A of t is equal to 18,000 times e raised to the 0.08 t. And we're done. Part B is now asking us to figure out after how many years will the gray squirrel population reach 25,000? So our A of t is going to be 25,000 here, and we want to figure out what is our value of t. How many years is it going to take us for us to increase an additional 7,000 squirrels? So we get 25,000 is equal to 18,000 e to the 0.08 t. And because this is a final exam and we're not allowed calculators, we want to keep this in exact form. So we just essentially isolate the t, get our answer, and boom. We're going to divide both sides by 18,000, which actually can be simplified. Right, both of them end in 3 zeros. So straight off the bat, we can cross out those last 3 zeros. So we're essentially just looking at 25 over 18 is equal to e to the 0.08 t. And now how do we get rid of that e? We have to take the natural log of both sides and use our properties of logarithms. So that left-hand side just stays as ln of 25 over 18. That right-hand side, that exponent, we can bring in front. And so we're looking at 0.08 t of ln of e. Ooh, that's a famous fact. Natural log of e is just what? Yeah, good. So we can replace ln of e with 1. And so we're looking at just 0.08 t is equal to ln of 25 over 18. And let's go ahead and divide both sides by 0.08 t, which we should probably put that in terms of a fraction. So I'll divide it first, and then off to the side, I'll write what 0.08 t as a fraction, or 0.08 is as a fraction. So 0.08 is the same as 800ths, which is the same as 4/50ths, which is the same as 2/25. So we're looking at t to be equal to ln of 25/18, all divided by 2/25. Our very last step is we can keep change flip. Ln of 25/18 as a fraction is just that over 1. And so when we keep change flip, that 25 jumps to the numerator, and we're looking at 25 ln of 25 divided by 18 all over 2. Don't forget your units. Years. That's it. No calculation needed. Yeah. If you left it as a decimal, I think that would be fine. Yeah. I don't know how the other professors grade, but yeah, I'm sure that it's always good to simplify. All right. Let's move on to the next question. Question 3. Ooh, we're dealing with an ellipse. So let's put all the x's to one side, which they kind of already did for us. I'm going to leave some space, then put all the y's together, leave some space, and then I'm going to go ahead and move that constant over to that right-hand side. We're completing the square twice. We can complete the square for our x first, but then our y, we're going to have to divide everything by 4. So let's first take care of the yellow. Our b value here is 4. Divide it by 2 and square it, aka our special key, and we get 2 squared, which is 4. That's what we're adding to both sides. And so now our yellow is in fully factored form. So we're looking at x plus 2 in parentheses squared. The y we're just going to bring down for the time being, not do anything. And then the -4 and +4 cancels out, so we have equals 0. Now let's go ahead and make that y² coefficient 1 by dividing every term by 4. So now we're looking at x plus 2 in parentheses squared all over 4 plus y² minus 2y, leave a little space, equals 0. Now the purple, yeah, question? As in like factor out the 4?
Yeah, like or what or like y squared what?
All right, so now we're ready to complete the square for our y. Our b value is -2. Divided by 2, you get -1. -1 in parentheses squared gives you +1. That's what we're going to add to both sides of the equal sign. And so now we can factor, and I'm going to just shrink everything. And so when we factor the blue, we end up with just our y minus 1 in parentheses squared. And this is all equal to 1, which means the denominator with our y minus 1 is just 1. And is it officially in our standard equation format for an ellipse? It is indeed. And so we're done. Did they ask us to find? They didn't ask us to find the center point, but what would be the center point of the ellipse? Yep, beautiful. -2, 1. Question? Yes.
Would we put the denominator as the square?
No, you won't. You can either write it as 2 squared and 1 squared, or you can keep it as 4 and 1. You'll get full credit. All right, question or part B is asking us to graph this. So if you know that your a squared is 4 and your b squared is 1, that tells us that your a is plus or minus 2, aka your x-intercepts, and then your b is plus or minus 1, aka your y-intercepts. But that only works when you're stemming from the origin, and we're not stemming from the origin here. We are stemming from our center point, -2, 1. So we want to plot that first, and then use our a values to go 2 units to the left, plot a point, 2 units to the right, plot a point. And then we want to use our b values to go 2 units or 1 unit up, plot a point, 1 unit down, plot a point. And then last but not least, create your ellipse by dashing it out between those 4 points. Yeah.
Circle that don't like a circle. We use one.
Well, it can't be a circle because it's an ellipse, so that means you're in good shape. But I think what you're getting at is if it just looks a little weird, I won't take points off for artistic ability. I'm not very artistic myself, so. But I will take points off if you do not label your X and Y axes or your proper scale. So make sure you label it. They did not say label any intercepts, so you're good. Yep. It doesn't have to be dashed. The reason why I do the dash is it makes it look a little bit more ellipsy. But yeah, you could have solid lines. Yeah. All right. Let's move on to the next question. System of nonlinear equations. They don't ask you to solve using substitution or elimination, so you have the freedom to do what you want here. I'm going to personally just do substitution. That second equation, y minus x equals 1, I'm going to bring the x over to isolate my y. And so I'm looking at y is equal to x plus 1. And I'm going to take this and put it in to my y in the first equation. So we're looking at x squared plus, in parentheses, x plus 1, close parentheses, squared is equal to 1. And now I'm going to solve for my x. So x plus 1 in parentheses squared ends up being expanded into x squared plus 2x plus 1. And then straight off the bat, we can combine our x squareds to get 2x squared. And then we can also subtract 1 from both sides. So the 1's actually cancel out. So we're looking at 2x squared plus 2x is equal to 0. Now we can go ahead and factor out a 2x. And when we do, we're left with x plus 1 in parentheses, which gives us our two potential x values to be x is equal to 0 and x is equal to -1, but I'll put it in ascending form. So now let's solve for our y, and lucky for us, since we already isolated the y in a previous step, we don't have to repeat and do extra work. I'm just going to bring that over, and we just want to solve for two values of y for when x is equal to -1 versus when x is equal to 0. Plug it in, and we get, in our first case, y equals 0, so the coordinate here is -1, 0. In our second case, we plug in 0 for x, so we get y is equal to 1. So our coordinate point is 0, 1. And then last but not least, we need to check to make sure both of these are indeed solutions that work. So let's plug in the first, and we can check verbally. -1 in parentheses squared is +1 plus 0 squared is 1. That works. 0 minus -1 is +1. Okay, our first solution is a go. Second solution, we get 0 plus 1 is 1. Good. And we get 1 minus 0 is 1. Both solutions work. And so we are done. Part B is to solve these systems of non-linear equations graphically. And so I'm going to write them down again below here. We have our x squared plus y squared equals 1, which is what? What is this? Our famous unit circle with radius 1. So let's plot that one for 0, 0. We go up 1, to the right 1, down 1, to the left 1. Okay. And then our second one is just a linear function. Y-intercept at 1, slope of 1. So y-intercept at 1, and then we go up 1 over 1, up 1 over 1. You don't have to plot all of these points. You don't have to, yeah, you can put the circle. You don't have to have it be dashed. It can be an actual circle.
Yeah, but I asked if you only need to do the circle and know the whole line.
Oh, you have to do the line too. It's saying graph the system. You want to graph both equations. Yeah. Graph the system on the axis below. This is our system, the two equations. And then it says clearly label the solutions to the systems. So that's our last step. So we have a solution here, which is our y-intercept. And then we have an x-intercept solution over here.
Oh, we have only two,
With only what?
we have two up front.
Yeah. So the cool thing about solving systems of equations is you can solve them graphically. They do take longer in certain cases, but we just solved the solution graphically, right? -1 comma 0 and 0 comma 1. These are our two solutions which we solved technically up here. I'm gonna move on to the next page, where we're now into a little bit of trigonometry. We're asked to evaluate and simplify and express your answer in radians. So square root of 2 over 2, you immediately want to think 45 degrees, pi over 4. So we have arc sine of square root of 2 over 2 is pi over 4. Arc cosine of square root of 2 over 2 is also pi over 4. And so if we're adding pi over 4 plus pi over 4, we end up with, what's a fourth plus a fourth? A half. So our answer is pi over 2. And we're done. Question 6. We're dealing with the difference quotient here. And so you can do this a few different ways. You can evaluate f of 1 off to the side, evaluate 1 plus h off to the side, or you can just all put it together and then simplify each step by step. I'm going to do it the latter since we're pretty proficient in this at this point in the curriculum, or we're done with the curriculum in the course. So 1 plus h, wherever you see an x, you're going to draw some parentheses. And then you're going to fill those parentheses with that 1 plus h. And then we have a minus f of 1. So again, draw your parentheses and then fill those parentheses with a 1. And this is all being divided by h. So now we just have to simplify. 1 plus h in parentheses squared is the same as 1 plus 2h plus h squared. Use distributive property to distribute the 2 in that second parentheses to get 2 plus 2h. Then we have to be careful here. When you're subtracting f of 1, you're subtracting the entirety of f of 1. So I put in those red parentheses to really show that you're distributing that negative to both terms. So you get minus 1 and then minus 2 all over h. And so a lot of canceling out occurs. We have a plus 1 here, a minus 1 here. We have a plus 2 here, a minus 2 here. So we're looking at 2h, and then let's combine some like terms too. We have a 2h and a 2h, which becomes 4h. So we end up with h squared plus 4h all over h. Factor out an h, and we get h plus 4 in parentheses all over h, so that the h's cancel out. And last but not least, in simplest form, we just have h plus 4. Questions at all on this one? Let's go ahead and move to the next page. Question 7, we want to find our average rate of change. which is our f of b minus f of a all over b minus a. And they give us our a value to be 0 and our b value to be 4. So we're looking at f of 4 minus f of 0 all over 4 minus 0. Well, f of 4, when x is 4, what is our y value? 3, good. And when when x is 0, what is our y value? Ooh, it's also 3. Means the denominator really doesn't matter, because what's 3 minus 3? And 0 divided by any number is 0. So our average rate of change here is just 0. You can also just look at it graphically. It's always going to be 0 when we're looking at what type of line. Yeah. You don't if graphically it's a straight line and you know it's 0. If it's not, let's say we had to take the average rate of change here, then you should show your work for that. But you don't have to, unless they explicitly ask you to write out the general formula, you don't have to write out the general formula. Sometimes they do though. So read the instructions. Okay. Question 8. Another trigonometric question. Ooh, we're dealing with some double angles here. We have sine of 2 theta, which is the same as 2 sine theta cosine theta. And we are asked to find, I'll highlight it in pink, this whole expression if tan is equal to 3/4 and tan is in our third quadrant. So tan is always positive in that third quadrant, but sine and cosine aren't. Those are negative values. So what we can do is first let's zoom in on what we have in green here. If our tan theta is 3/4, ooh, Pythagorean triple. Really be on the lookout for Pythagorean triples tomorrow. They're very commonly used on exams and standardized tests. Pythagorean triple, like a 3, 4, 5, 3 squared plus 4 squared equals 5 squared. And so tan theta, if our theta is here in our right triangle, TOA in SOHCAHTOA, our opposite side is 3, bless you, and our adjacent side is 4. Oh, we have a 3, 4, 5, which tells us that our sine theta is 3/5, and our cosine theta, our adjacent over our hypotenuse, is just 4/5. You can use Pythagorean theorem as well. My iPad keeps glitching. But yeah, it's good to know the Pythagorean triple because it just saves you a lot of time. And so now let's do some substitution. We know that sine 2 theta is, and I'll maybe color code a little bit more. This sine of 2 theta, we can replace it with 2 sine theta cosine theta. And then we have our plus cosine theta. But now we can replace it even more because we know our cosine theta and our sine theta. So let's put in our numbers. 2 sine theta is 3/5. Cosine theta, yeah, 4/5, plus a cosine theta, 4/5. Now let's simplify. 2 as a fraction is just 2/1. 2 times 3 is 6, times 4 is 24. 5 times 5 is 25. So 24/25 plus 4/5. How do we get that common denominator? Multiply it by 5/5. So we're looking at 20/25. And ooh, I made a mistake, right? I was assuming that all of these are positive, but we're in that third quadrant. So is sine and cosine both negative? Yeah, so we have to go back and make sure we incorporate those negative values. Doesn't change that first result because a negative times a negative is a positive, but it does change that last result. Instead of adding 20 over 25, we're subtracting 20 over 25. And so our final answer is just 4 over 25. And we're done. Questions? No, no. It depends on the trig function. The first and second quadrants are only positive with sign-related functions. But don't forget to use your acronym. All students take calculus. The S, T, and C quadrants tell us where sine, tangent-related, sine-related, tangent-related, or cosine-related functions are positive. So the first and second are only positive for sine. Whereas tangent-related functions, those are only positive for 1 and 3. And then cosine-related functions, those are positive for 1 and 4.
How do you get a 2 sine theta, cosine theta out of sine?
Yeah, this is a double angle formula that you have to recall. I'll maybe put in the slide of all the angles you guys should know. Here. Yeah, so these are formulas that you need to know. Sum and difference formulas, that will always pop up at least once. What we have in orange here, these are our double angle formulas, and we use that first one for that last problem we solved together. And then we have also half angle formulas. So create flashcards, make sure you know these. They're important. Okay. We're going to continue. Question 9, another trigonometric question. We're asked to solve this equation, and lucky for us, they give us bounds, which means we have some definite answers here. And the first thing that we should do is let's subtract 3 square root of 3 from both sides. So we're essentially just looking at 4 sine theta is equal to, think of square root of 3 as like x. So if we had a 1x minus a 3x, that would just give us negative 2x. So a 1 square root of 3 minus a 3 square root of 3 would just give us a negative 2 square root of 3. And now we can go ahead and divide both sides by 4. So we're looking at sine of theta is equal to 2 over 4 is the same as 1/2, so we get negative square root of 3 over 2. Let's draw out our quadrants. All students take calculus. Because 2 over 4 is the same as 1/2. And so we can rewrite this as -1 square root of 3 over 2, which is the same as negative square root of 3 over 2. Back to this, all students take calculus. Our sign is negative. So the two quadrants we're really honing in on are those quadrants below our x-axis, 3 and 4. So those are the only areas where sign is negative. And again, we're only thinking about one full revolution around a circle. So we're going to only end up having two solutions. Square root of 3 over 2. What special angle gives us that when we take the sine of it? Pi over 3, exactly. So our reference angle is going to be some form of pi over 3, which means that's 60 degrees. So we're going to go down 2/3 here, looking at that. And then we're going to go down 2/3 here. So these are the two angles we're looking at, this guy here and this guy all the way here. Two different colors. If this reference angle is pi over 3, what is pi plus pi over 3? 4 pi over 3. And then what is 2 pi minus pi over 3? Get the same denominator. It's just 6 pi over 3 minus pi over 3. 5 pi over 3. So therefore, theta is equal to 4 pi over 3 and 5 pi over 3. And we're done. Questions? Right, let's keep going. Question 10, we're just asked to use this table below to solve our equation f of x is equal to square root of 3 over 2. And so when f of x is square root of 3 over 2, what is our y? 2 pi over 3 and pi over 3. Good. Always double check that you're covering all your bases. You're checking all solutions. Move on to the next page. Question 11. We're dealing with finding our angle theta when we have a radius and our arc length. So our formula for that is our theta is equal to S over R, Soik over Rachel, arc length over our radius. Thing you have to keep in mind is theta is always in radians in this formula. And so let's just plug in. If we have our radius is 10, and then our arc length is 25, then we just divide the two by each other in order to get our theta. theta is equal to 25/10, which just tells us that our theta is 2.5 radians. And we're done. Question 12. Ooh, we have a Psalms formula. Evaluate sine of pi/3 plus pi/6. Our sine of alpha plus beta. What do we recall from this? When we're dealing with sine sums, the signs stay the same, but the pairings are different. So our pairing is going to be sine alpha cosine beta, keep the same sign, still positive, plus cosine alpha sine beta. And our alpha here, we're going to let that be our pi/3. And our beta is going to be pi/6. So now let's plug in. We get sine of pi/3 times cosine of pi/6 plus cosine of pi/3 times sine of pi/6. Sine of pi/3 is our square root of 3/2. Cosine of pi/6 is square root of 3/2. Cosine of pi/3 is 1/2. And sine of pi/6 is 1/2. Square root of 3 times the square root of 3 is just 3. 2 times 2 is 4. 1 times 1 is 1. 2 times 2 is 4. And 3/4 plus 1/4. Oh, love when it is so clean in the end. So our final value is 1. Yes, question C. So another way you guys can solve it, thanks to Adam, is much simpler. What's pi/3 plus pi/6? It's just 1/2. If you're not convinced, do the common denominators, and you get 2 pi/6 plus 1 pi/6 to give you your 3 pi/6, which is once again pi/2. And we know that sine of pi/2 is just 1. So won't work all the time, but you should go down that avenue first because it will save you time.
This one just like unintended.
Yeah, just adding these two fractions up, simplifying and seeing if it's a famous angle that you can take the trig function of.
How do you know it's not like, I'm gonna get a result now, but it has to be like an angle?
It would have to be like one of your famous angles, 0, 30, 45, 60, 90, or some coterminal angle of that for you to solve. But like, let's say you were given, this ends up being like in degrees, sine of 15 degrees. I don't know what sine of 15 degrees. I'm going to have to use my sum and difference formulas to do 45 minus 30 degrees because I know sine of 45, I know sine of 30. I can use my sum and difference in order to solve sine of 15 degrees. Yeah. Okay. question 13. Everyone should get this question right on the final exam. Whether it's distance formula or midpoint, you have to get these questions right. But please read the instructions on what it's asking. I had some students who it was asking to find the distance, but they used the midpoint formula and they got all the points off. No, don't do that. So our distance formula, I'll write out the general formula here, but they're not asking you to write it down. Your difference between your two x values squared plus your difference between your two y values squared. And then I'm going to label my x1, y1 and my x2, y2 so I can easily just sub it in and then simplify. We end up with 10 minus -2 in parentheses squared plus 0 minus 5 in parentheses squared. The two negatives become a positive, so we're essentially just looking at 12 squared plus -5 in parentheses squared, which is 144 plus 25, which gives you 169. Exactly. The square root of 169 is just 13. And we're done. Question 14 is a solving exponential equation problem. And so, zoom in on this. Let's write it out again so we have some space. 2 in parentheses 5 plus 3 raised to the x plus 1 is equal to 100. We want to express our answer in terms of logarithms. And let's utilize our inverse operations in order to isolate that x. So I'm going to first divide both sides by 2. So I'm looking at 5 plus 3 raised to the x plus 1 is equal to 50. And then I'm going to subtract both sides by 5. So I'm looking at 3 to the x plus 1 is equal to 45. And I need to get that x out of the exponent, so I want to put this into logarithmic form. If you know the conversion from exponential form to logarithmic form, you can go about it that way. If you forgot the whole conversion of the form, you can also just take the log of both sides, and then it'll eventually get you into that log form by using your logarithmic properties. Our power property, bringing that x plus 1 exponent into the front. And so now you're looking at x plus 1 in parentheses times our log of 3 is equal to log 45. I'm going to divide both sides by log of 3. And so now we're looking at x plus 1 is equal to this log 45 divided by log 3 can be written with a log base of 3. So we can rewrite this as log base 3 of 45, so it looks a little cleaner. And then the last step in order to really isolate that x is to subtract 1 from both sides. So you get x to be equal to log base 3 of 45. I'm going to put that in parentheses so that I know that it's separate from that -1. And this is your answer. We're done. Yeah. Yeah, I utilized the change of base formula. If you went straight into converting into logarithmic form from up here, we had our whole 3 to the x plus 1 equals 45. This is the same as log base 3, right? Our base is 3. Of 45 is equal to x plus 1, right? 3 to the 45 equals x plus 1. Questions on this one? No? Okay. Let's keep going. Page 10, number 15. We're just asked to find the domain of this function. So what are all of our possible x values? We're including -6, that's our lowest, and we're including 11, that's our highest x. So hard brackets, -6, comma 11, hard bracket, done. That is why it's so important to not take an exam front to back. Because this question is worth 4 points and it took us less than 2 seconds to answer it. You want to answer all of your easiest questions first and then go back, answer the easy questions that are more time consuming next, and then go back and answer those harder questions last. Also, looking at hard questions and not knowing them, but having them be in the back of your mind while you're answering the easy ones, usually when you return back to the question, things start clicking, and then you'll know the solution later on. Question 16, we have a piecewise function, and we're dealing with solving a composition. So, do what's inside first. We want to evaluate what is g of -1. This is our g function. It's just ln of -1 plus 2, which is ln of 1. And what's our whole famous fact of ln of 1? ln of 1 is, 0, right? Remember, recall that natural log is the same as just log base e. So if we're looking at log base e of 1, that's just asking us e to what power gives us 1? E to the 0 power gives us 1. So ln of 1 is 0. And now we want to evaluate, okay, well, what's f of 0? Well, f of 0 is the top equation of this piecewise function because our x is including 0 there. So we're just going to plug in 0 for x in what we have in yellow. And we end up with our final result to be -1. And we're done. Going to move on to question 17. Where we're asked to find the inverse and evaluate it at 2. And so 2 ways to go about this problem. First way, you can take the inverse. So how do we take the inverse? We write our function, we switch our x's and y's, and then we solve for our new y. You'll notice that this is the longer way to solve this problem. I'm going to go ahead and use distributive property. Gonna add xy to both sides, subtract 4 to both sides. So I'm looking at xy is equal to 4x minus 4. And then last but not least, I'm going to divide both sides by x. So I have y is equal to 4 minus 4 over x. Put it into inverse format, and we have our inverse. And they're asking us to evaluate it at 2. So f inverse 2 is just 4 minus 4 over 2. 4 over 2 is 2, and 4 minus 2 gives you 2. One way to solve it. Another way you could solve it is, what's the definition of inverse? Your x and y values are switched. So if you're evaluating it at x equals 2, and this is your inverse function, what you can also do is set this to be your y value and your original function. So if we have f of x is equal to 4 over 4 minus x, we're going to plug in 2 for our y value and solve for your x, and that would also be your answer. So 2 is equal to 4 over 4 minus x, then cross multiply. You get 2 in parentheses 4 minus x is equal to 4. Instead of distributing, I'm going to just divide both sides by 2. So we get 4 minus x is equal to 2. And then if you add x and subtract 2 on both sides, you get x's again, 2. And this is just another way to solve for your solution by understanding the definition of your inverse. And it'll save you some time. We were lucky here that your input ends up being the same output value. That's not always the case. Okay. Question 18. We're asked to sketch the graph negative e to the x plus 2. And then label the horizontal asymptote and intercepts on your graph. So that negative e to the x tells us we have a reflection over what? Yeah, our x-axis. And then that plus 2 tells us that we have a vertical shift up 2. So remember, do the reflection first and then go up 2. If you forget, what you can always do is just plug in really good points. If your x is 0, e to the 0 is just 1. And we have that negative in front, so it's negative 1. And negative 1 plus 2 gives you 1. So we know that that's a point. And can we plug in any more points? We can put in x is equal to 1, because we know e is about 2.718. And so then we're looking at e to the first, which is a negative 2.718. And if we add 2 to that, then we just get a positive 0.718. So 1 comma positive 718. I would say those are probably the most that you could do without a calculator. You could do more, it's just, it would involve more time. So let's not do that. But what do we know about our famous graph, e to the x, and I'll put that off to the side here so we can very easily identify our horizontal asymptote. E to the x looks something like this. It's the undercusp of the lowercase letter e. And so our horizontal asymptote here is at y is equal to 0. Which means if we reflect it over our x-axis, that doesn't change our horizontal asymptote. It just flips the graph entirely. And then moreover, we have that vertical shift up 2 units. So that will shift our horizontal asymptote. So if our new point, we're going to move this pink up 2 units, that tells us that our new horizontal asymptote is at where? Yeah. So our new horizontal asymptote, y is equal to 2. And then let me do this in maybe orange. So we're looking at something like this. E to the negative x plus 2. So now we're ready to put it all onto our graph. I'll do dashed for the horizontal asymptote. Don't forget to label it, y equals 2. And then now we're ready to draw in our graph. And there we have it. Our f of x is equal to negative e to the x plus 2. We are also asked to label our intercepts. So I'm going to go ahead. This is 0, 1, which is our y-intercept. And we should label our x-intercept, but we don't have to put a coordinate point. And that's it.
This is in the,
Mm-hmm.
so like the, horizontal asymptote, sometimes like it touches the 2, but it's like very, very far.
It touches
Like, okay, I'm asking about
like this part here. Oh, you're asking about the domain and range?
Yeah, I never know, like, I should do a hard bracket or soft bracket, because it's like, it does eventually reach to it.
It's never going to reach it. It's going to get super close, but the definition of asymptotes, you'll never hit. Whether it's a horizontal asymptote or a vertical, it'll get very, very close. And even graphically, it'll look like it's touching, but it won't ever touch it, which means you're always going to use the soft brackets. Yeah. Mm-hmm. I wonder if they ask you on the next question, the domain and range. No. Why don't we do that for this, though? What is the domain of this function? Yeah, it's all real numbers. We have no restrictions for our x, negative infinity to positive infinity, but we do have some restrictions for our range, for our y values. It goes from what? Yeah, negative infinity all the way up to 2, but not touching 2, so it's soft bracket. All right. Let's go ahead and move on to our question 19. I will say you guys will be graphing a lot on the final exam. So get a good foundation for graphing and make sure that you are properly setting up your axes each time and putting in a proper scale. So we want to graph this function g of x is equal to x cubed minus 2x squared minus 3x. Straight off the bat, we can pull out a greatest common factor. I'm going to pull out an x so that I'm left with x squared minus 2x minus 3 in parentheses. And then I'm going to factor even more. I can factor it into x minus 3 and x plus 1. And that helps me out a lot because that gives me all of my x-intercepts, -1, comma 0, comma 3. Do not forget this x-intercept here. Whenever you see an x that's pulled out, that gives you an intercept, a 0 at 0. I'm going to label, these are all of my x-intercepts. So we have -1, we have 0, and we have 3. Our highest degree here is 3. We're looking at a cubic function, which means, and the coefficient in front of that 3 is just 1. There's no negative in front. So our parent function of x to the third looks something like this. But because we have all these distinct zeros, it's going to be more pronounced. It's going to look something like this. So now we really have a feeling of what we're looking at here, and we can officially put in our rough sketch. If I can draw. There we have it. Don't forget to label your function. We're going to label all of our intercepts. So we have an x-intercept here at -1, comma 0. We have an x and y-intercept at the origin. And we have our last x-intercept at 3, comma 0. Oh, I don't know. Should be. Yeah, let me fill that in. Should be x cubed minus 2x squared minus 3x. Yeah, thank you for that. Yeah.
You haven't, actually one of the,
Ask me that question again.
graph.
That's fine. You would get full credit. Yeah. Mhm. Okay, question 20. Another graphing question. We're asked to graph a logarithmic function this time. So negative log base 3 of x plus 3. By transforming our log function log base 3 of x. And so what do we know about log base 3 of x? Well, it's the inverse of our exponential function, which is 3 to the x. And we know exponential functions look something like this. And inverses are reflections over our line y equals x. So this logarithmic function is going to look something like this. It's shooting down and it's very slowly growing. So knowing that, why don't we first, I'll plot maybe the log base 3 to the x just off to the side here. I don't want to crowd our graph. But what's that famous point that we should put in? 3 to what power gives us a nice clean number? Yeah, 3 to the 0 power gives us 1, which means we have 1 comma 0 as our main point. And then we have this, remember, everything is opposite when we go from exponential to logarithmic. So instead of having a horizontal asymptote for logarithmic, we have vertical asymptotes. X is equal to 0, and then I'll sketch out, and then I'll answer your question, Ariana. All right, so that's the shape that we're looking at. It's just now we need to transform this with that +3 and with this reflection in front. What's your question?
So since like the exponential graphs always have the intercept of 0, 1, or the logarithmic graphs always gonna have the x-intercept of 1, 0?
It's gonna have an x-intercept of 1, 0 if you're looking at the parent functions. But once transformations take place, like if you have a vertical shift or a horizontal shift, then the x-intercept will change. Yeah. But the parent functions, yes. And you always want to know that famous point. Okay. So now we're ready to plot our negative log base 3 of x plus 3. And I'm going to put a nice little t-chart off to the side so that we can get in some good points here. And so what is, we want inside the parentheses here to be what number to give us a good point. Again, 3 to what power gives us a nice clean number?
1, 0.
Yeah. So if our y is 0, how is that possible? What value of x makes this inside parentheses 1? Not -2, right? Because -2 plus 3 gives us 1, and then 3 to the 0 power gives us 1. All right. So we have when x is -2, our y is 0. And so we can plot that, -2 comma 0. And then I think you're starting to realize, all right, this +3 ends up moving what? Yeah, and more specifically, what does it tell us about our vertical asymptote? Our vertical asymptote is at x is equal to, yeah, exactly. So I'm gonna plot the vertical asymptote now. I'll do a dashed line once again for that. So we have our x is equal to -3. And then can we put in, we should probably put in one more point. Yeah, when y is 1, let's do. So when y is 1, we have 1 is equal to negative log base 3 of x plus 3. And so we get 3 to the power of 1 is 3, which is equal to, let's actually, I'm going to divide this by a -1 first. So 3 to the power of -1 is equal to x plus 3. So what value of x makes this true? Subtract 3 from both sides. Get a common denominator. And we're looking at 1 minus 9 over 3, which is -8 over 3. -8 over 3 is, as a mixed fraction, -2 and 2/3. All right. The only reason why I did that last point is because in the question, it's explicitly asking us to graph the function, so we should really have more than 1 point. If it was sketching, then we really just need 1 point and we're good. So -2 and 2/3, comma 1. So 2 and 2/3, comma 1. About there. Okay. So now let's draw it. Like, why is it looking weird? And then I was like, oh, it's because it's negative log, so it's reflected. Okay, so it's gonna look something like this. And then we have our f of x is equal to negative log base 3 of x plus 3. And we're done. Yeah.
Chris?
It is, it's just, it's, a reflection is taking place too. So this is what flips over the, x-axis. Because log base 3, remember, e to the x is like this. And then our inverse is the reflection across our line, y is equal to x. But then it's a negative of this, so then it's a reflection over our x-axis to get this.
I'm confused because like
Yeah.
how can it be an inverse and a reflection at the same time?
Well, because reflections are transformations. So think of horizontal shift, vertical shift, and then reflections across your x-axis or your y-axis. Those are separate from inverse, which also technically is a transformation, right? It's a reflection across the line y equals x. So think about it as two conditions taking place. You're reflecting over the line y equals x, and then you're also reflecting a lot along the line your x-axis. Yeah. So if you think again, think just back to parent function. We have e to the x, and then your ln of x, and then it's reflected over our x-axis, and then it's going to look something like this, which is correct, right? Doesn't it look like something like this?
Yeah, yeah, I
Yeah.
know how like
But logic, like, are you understanding the
Yeah, I just
difference
don't
there?
understand how to look at the and then recognize that it's not only an invert, like not only a reflection, but also an inverse, because I only see like one negative. Like usually I look at like f to the -1 of x. And then
Oh, because you're thinking, when I say inverse, I'm going from exponential function to logarithmic. Because logarithmic and exponential, they're inverses of each other. Yeah. So it's like going from e to the x to ln of x, or 2 to the x to log base 2 in this case. Yeah,
it's an inverse if it's logarithm.
exactly. You got it. Cool. Any other questions? Right. Finally, our last question, which I do want to make a special point towards, and my boss wanted me to tell you guys this too. Last question on the final exam is worth 10 points. It is most likely going to be graphing a trigonometric function and dealing with amplitude, period, horizontal shifts, vertical shifts, and then sketching it out on the bottom here. It is very straightforward if you read the instructions, but it is worth a lot of points. And if you get -10 on this, you're already down to getting a 90 for the highest possible score. So really know this stuff. It will be on there, guaranteed. And it's the most weighted question on the final exam. So we have let f of x be equal to -2 sine in parentheses x minus pi over 2 plus 1. What's our amplitude here? Not -2. Yeah, +2. It's the absolute value of your A value. So our amplitude is 2. Good. Our period, we're dealing with sine here. So our period is just 2 pi over the absolute value of B. And our B here, lucky for us, is just 1. So we just get 2 pi over the absolute value of 1, which is just 2 pi over 1. And that gives us 2 pi. The horizontal shift, this guy over here, and that tells us that we are shifting pi over 2 units to the left or to the right? Yes. And then finally, we're asked to sketch one complete period in the appropriate interval. So our interval, I really don't like the fact that they use these lowercase b, because lowercase b is different from the uppercase b value up here. And that lowercase b is referring to that horizontal shift. So essentially, we're looking at our interval from pi over 2 to pi over 2 plus 2 pi over k. And what's our k value? Our k represents our vertical shift, which is 1. So we'll simplify this a little bit more now. Pi over 2, and then comma pi over 2 plus 2 pi over 1. Let's get a common denominator so that we can combine those fractions. And so we get 4 pi plus pi is 5 pi over 2. And then we have that pi over 2. That's our interval. So let's plot this. I'm going to put in pi over 2. I'll put in pi. I'll go up increments of 1/2 pi. So pi over 2, pi, 3 pi over 2. 4 pi over 2 is the same as just 2 pi. And then we have our 5 pi over 2. And then create your table of values. You want to pick good values, and we just did. We just picked all of our x values here. We just need to evaluate them. And then I'm also going to write the equation of our function again. It's -2 sine x minus pi over 2. Plus 1. That plus 1, aka that vertical shift, tells us what? It is also the equation of our midline. Good. So I'm going to create a little dashed line for our midline. And if that's our midline and our amplitude is 2, then what's our absolute max going to be? What's 2 plus 1? So we can finish up our scale on our y-axis. You know, we're just going to go up to 3. And what's our absolute min? We're going to go 2 below our midline. Yeah. Good. Okay. So now let's plot these points. Pi over 2 for x. Pi over 2 minus pi over 2 gives you 0. Sine of 0 is 0. All of this shoots to 0. We have that plus 1, and we get y is 1. Right? Pi. Pi minus pi over 2 is pi over 2. Sine of pi over 2 is 1. -2 times 1 is -2. Plus 1 gives you -1. 3 pi over 2 minus pi over 2 is 2 pi over 2, also known as pi. Sine of pi is 0. All this shoots to 0, and we get 1. Two pi, also known as 4 pi over 2 minus pi gives you 3 pi over 2. And 3 pi over 2 is also right on the unit circle, 270 degrees. Sine of that gives you -1. -1 times -2 gives you a +2. Plus 1 gives you a 3. And then 5 pi over 2 minus pi over 2 gives you 4 pi over 2, which is the same as 2 pi. Sine of 2 pi gives you 0. And then all this shoots to 0, and we get 1. So now let's plot these. We have pi over 2, comma 1. We have regular pi, -1. We have 3 pi over 2 back to 1. We have 2 pi all the way up to 3. And then we have 5 pi over 2 back to 1. So when we sketch this out, we end up getting something like this. And that's it. So that completes, let me just double check, yeah. That completes our final exam, sample 8A.